For my presentation, I decided to analyze and explain the perusal article entitled Neuroscience Needs Behavior Correcting a Reductionist Bias, written by John W. Krakauer. The reason I chose this article in particular was due to its fascinating tendency to strive towards rectifying a serious problem facing modern psychology, that being a complete disregardance for behavioral psychology to instead erroneously focus only on physical mechanisms within the brain. This phenomenon is known as reductionism. The challenge that reductionism poses is that it underestimates the importance of behavior as a scientific domain. This is a problem because you cannot fully understand the brain without understanding what it evolved to do. And that means studying behavior not just as an output, but as a dynamic, structured, and complex process alongside your studying of the mechanisms within the brain. The problem with the reductionist approach in this article can be explained with the following analogy. Adhering to reductionist ideology when studying behavior without incorporating behavioral psychology is like trying to understand the software your computer runs by examining only its physical parts. It doesn't offer nearly enough information without utilizing both schools of thought together. Therefore, an understanding of the three levels of analysis and processing, or Mars levels of analysis, is paramount. Mars levels of analysis can be broken down into three simple categories. First is the computational level, which relates to what the brain is actually trying to do, such as making a decision, recognizing a person's face, etc. Next, the algorithmic level, which relates to how the brain actually plans on doing that. And lastly, there's the implementation level. That part relates to what parts of the brain are going to make that thing happen. Throughout the article, Krakauer makes the argument that reductionists limit their understanding by only analyzing information within the implementation level while disregarding the previous two. An example of this within the article can be found in the form of the article's examination of mirror neurons. Mirror neurons were found first in monkeys. These neurons fired both when the monkey did something and when it watched someone else do the same thing. People assumed this meant the monkey understood what it was seeing, but there was no real behavioral proof to back that up. Without showing that the monkey's behavior actually changed based on the understanding, the claim was really just a guess based on brain activity examined. So, in conclusion, Krakauer's article highlights a crucial flaw in modern neuroscience: its over reliance on reductionism. By focusing solely on brain mechanisms and ignoring behavior, researchers risk missing the bigger picture. Just like understanding a computer requires more than just examining its hardware, understanding the brain demands that we study what it's doing, how it does it, and where it happens. Mars's three levels of analysis, for example. Without integrating behavior into the equation, as seen in the mirror neuron example, neuroscience draws incomplete or even misleading conclusions. Moving forward, a true understanding of the mind requires treating behavior not as an afterthought, but as a core part of the scientific study. Thank you.